previous lesson video, we discussed the nominal interest rate R and effective interest rate I, and the equation to determine. In this video, I want to show for different scenarios when we have the number, can we be able to know whether that number is effective or nominal interest rate. And then we go over to apply that in problem 4. So let's go that in the slide, and that is only one slide for today's lesson with a nominal and effective interest rate with different interest statement, and we need to interpret correctly whether it's nominal or effective. And when it's nominal effective, we need to know what is the compounding period, because that when we know the compounding period, we can determine the number of compounding periods so that we can apply the equation to determine the effective interest rate. So let's go to the first one. 15% per year compounded monthly. Per year compounded monthly. Nominal or effective. And as you can see here, we consider the nominal when the interest rate is spread over the period of time different from the compounding period. You see, per year and compounded monthly. So it's different. And then it have to be nominal and compounding period per month. That state clearly there. So that nominal interest. So when you see that 15% per year nominal, we cannot use that number to apply in the equation that we learned for the remaining of engineering economics in the second portion of this class. We have to convert that to effective interest rate first. That's the first scenario. The second scenario, 15% per year. And in this case, the problem very brief, statement very brief. And when they don't say anything compounding period, just 15% per year, you just assume that it will be effective and the compounding period is the same as the interest period. Make sense? So when the problem give that, just 15% per year or 1.5% per month, then, and they don't say anything about the compounding period, then it will be effective. And that compounding period is the same as the interest period per year, then it will be year. Make sense? Then the third one, effective 15% per year compounded monthly. Now this is a little bit tricky. Per year compounded monthly, so something like same the scenario 1. However, they say that effective. So it will be overruled. On of the statement we are talking about, they already say effective 15% per year. So regardless of what they say, it will be effective because they say very explicitly effective 15% per year. So that effect 15% per year already effective. And of course, the comparative period still monthly. So that effective per month because it explicitly says effective. Make sense? So when the problem gives you effective explicitly, that will be effective. And of course, the compounding still follow that they say comparative monthly. It will be month. 20% per year, comparative quarterly. Per year, comparative quarterly. And that exactly same as the scenario number 1. 15% per year, comparative monthly. This is 20% per year, comparative quarterly. And as you can see there, the interest period is spread per year. Compounding period is quarterly. So 3 months, they are not the same. So it will be nominal. And compounding period will be quarter. Nominal and quarter. The next one, the fifth one, 2% per month. It's similar to the second scenario, 15% per year. They don't say anything about compounding period. Then it will be effective, and compounding period same as the interest period they express, which is per month. So it will be effective monthly. The sixth scenario, effective 2% per month, comparative daily. So the per month and daily are not the same. However, they already say effective. It will be overrule everything. that will be effective and compounding period is per day. Same as the third scenario. The last one, point 0.1% per day, and compound it continuously, very tiny of time. So with that, as you can see, the interest period is spread per day, compounded it continuously, every part of million of the second, very small. Then they are not the same anyway. When they are not the same, the interest rate given if nominal, and compounding period is continuous. So that's what you differentiate between the different statement and be able to figure it out. The problem give you either effective or nominal. If it's nominal, then apply the equation that I'm going to show in problem 4. Now, if it's effective, then you just apply the any equivalence equation that we talking about for the rest of the class, and of course the next classes. So with that, I assume you understand what is the difference between the nominal and effective. When the problem gives us, we can be able to find out that is effective or nominal. And that let's apply to here with the equation we learned. Change plan to place money on a jumbo certificate of deposit that paid 18% per year and compound it daily. What effective rate will she receive? Yearly, semi-annually. So first, the problem gives you 18% per year, compounded daily. So with that, we see it will be the interest period is spread per year, compounding period per day. 1 year is 365 days. Then it's not the same. Then it will be nominal. That nominal. So when we have that, then what is effective interest rate? Again, we can apply that equation I equal to 1 plus R over M power M minus 1. So let's do that now here. So the first scenario, per year, yearly per year. So I per year, then it equal to equation 1 R plus M over M minus 1. And in this case, we have 1, nothing. Okay. R have to be spread over the same period of time. We want R per year, yearly. Then R have to be per year. And this 18% per year. So we can apply that to 0.18%. Because they spread the same interest period. Divide by the M, number of compounding period. It compound daily. And we talk about years. So the number of compounding period is 365. This compounded daily for 1 year, 365 times compounding. Power M, 365 and minus 1. So from that we get 19.72%. So someone tell you, oh, the interest is 18% per year, but it actually, if it compounded daily, the interest you actually have to pay is 19.72%, which is almost 2% higher. 1.72% higher. And that will be per year. Very important, we need to spread what is this interest, in this case per year. And then the next one is semi-annually per half year. Then what will we do? We apply the same equation. However, it's spread over the same period of time. So as you can see, this is the I we want to find out is per half year. Then to apply the equation, R have to be per half year. Have to be spread the same interest period, we have 18% per year, that is R. So per half year have to be equal to 18% per year divided by 2 half year. So, and that is nominal, and that only 9% per half year for the nominal. So for nominal, you can divide, but not effective. So divide by the number of compound period. For 1 year, 18%, half year, divide by 2, 9% per half year. So with that, we can be able now to apply for I in this case is 1 plus R. R here have to be the same interest period. So not 18%, but have to be 0.9%. So 0.09 divided by M. Number of compounding period per half years have to be 365 divided by 2. And you can see that because that half year over 365 divided by 2 for half year. You can say rounding up like 180 days or 165 divided by 2. Just bottom line, that should get approximate the same answer. So you can get, okay, half year, so 180 days. But technically a little bit more, 183.5. So I divide by 2 just to show you visually that it have. So it will be 9.42% per half year. So it's a little bit tricky in here. So keep in mind, R and I in that equation have to be spread over the same periods of time. And I think that is the most challenge for today's lesson for effective and nominal interest.